So, I don't know if I can even read things that are around here, so I'm going to try. Briefly, I have to talk about secure delivery. That's where I work. That's who's paying me to be here today. So we do a lot of this sort of thing, a lot of AppSec program work with organizations. I'm not going to do too much about it. If you're curious to know anything more about us, reach out to me afterwards. I'm Grant. I'm often known as the OWASP guy, but this is one of the few places where I'm not the only OWASP guy. I'm one of the leads for the Cornucopia project. I co-lead the Application Security Curriculum project. I'm on the board with, I was hoping there'd be more than two of us here, but with Martin. So I've been elected, fortunately, to represent you guys. The main takeaway from the slide is where you can get hold of me. So, REWTD, Root Demon, you'll find me on the Slack channels. Reach out to me if you have any questions or if you want to chat, or if you have concerns about the Foundation or about programs or projects I'm involved with. An alternative title to this presentation could be Scaling Application Security in Large Organizations. And, well, some of the programs, some of the projects that we use to do that. I have very little time, so I'm going to try and flip through this as quickly as I can. So to start thinking about application security, we're going to have to define it. So let's draw a little bit of a boundary around that. Most people in the room here are involved with application security, but I like to try and get the definitions clear so that we know what we're talking about. Cybersecurity is this big thing that all of us are involved with, that we do quite a lot of. It covers everything from identity management all the way through to whether your printers are storing data on them or not, and everything in between. The cybersecurity component that we have to deal with, that I have to deal with a lot, is a very small part of that, application security. Now, applications, or the way in which you build applications can be secure, but there are many ways that things can go wrong, either in how the code gets written, or how you're pushing that code out to the actual production environment, so your pipelines. There's lots of parts and components that can be manipulated in different ways. When we're talking about the quality of supply chains, so your source code that you're using, third-party libraries, those sort of things, when you're talking about the way in which you're pulling code in from other teams, other components within your organization, the way that you're compiling that and putting it out onto a whatever production environment you're using, we're talking about a whole bunch of different activities, from designing all the way through to writing code to running code. So what we're actually talking about is product security. So it's not just applications, it's the whole product pipeline. Now, it's pretty clear, but quality as an intrinsic part of security, or as an intrinsic part of your product, seems very ethereal. So let me try and get a little bit more practical. This is the IEC 25010 model. This is the system and software quality model. Go on again. ISO models, as a general rule, have left to right importance. So things on the left-hand side are more important than things on the right-hand side. If it isn't functionally suitable, if it doesn't do what it's supposed to do, then it's not worth building the code. It's not worth having the application. You'll notice that I put a nice little block around the part that we're talking about. That's quite far down to the side of the screen. This is more important to businesses than this is what the model's telling us. Mostly because these are things you can see, that our customers can see. These are things that our customers never see, or if they do see them, it's because we badly messed up somehow. So, a product's security is an intrinsic quality of how well we do it, the quality of the code that we write. But how do we go ensuring that this quality is kept at the right level and do that at pace? These are the two sides of that equation, right? This is our very secure, this is how fast we're delivering, and most organizations think that this is how security needs to happen, right? Your appetite of risk determines whether you're closer to the security side or whether you're moving faster. But this is fundamentally flawed. This is not how this model works. the ability to develop and release changes into production very quickly is a benefit, a plus side for security. Because it means you can get changes out there, fixes out there quickly as well. So going with a DevOps model, that's how you get more secure software. You can improve things quicker, you can find issues. You've got code that's straightforward, easy to extend, because otherwise you wouldn't be able to deliver at pace. Delivering slowly isn't more secure. It's fearful. If you're afraid of changing the system, then the system is not secure. That's the takeaway from that slide for you. Taking all of this into account, security incident is really a trailing indicator of low software quality. Problems set in long before you have that security issue. So security incidents tend to indicate long-term trends. So we've been doing things badly for long enough that our software has been breached, that our code has been breached in some way. How do we manage to do that with some kind of leading indicators? So these are the 4 metrics that matter. If you've never read Accelerate, I strongly recommend you get a copy of it. If you have read it, then you'll know what I'm talking about. This is the summary. This is the book in essence. These are the things that DevOps teams need to worry about. Right? So if you're doing well on these 4 metrics, then you're doing delivery well. So we need to ensure that our security aspects doesn't mess with how fast delivery can happen, doesn't mess with the speed at which the organization can move. So the non-functionals, so all of these are functional requirements. The non-functionals can negatively impact any of them, right? Adding security can modify how quickly we can get things out into production, what the lead time becomes. So non-functionals can affect everything here. Security, though, is interesting because improving security doesn't actually necessarily improve any of these. Better security can only mean negative in this side. So it's important to balance that, because the moment you affect this, you're going to affect the business is going to kick back against the security controls, the security concerns you have. So to look for some specific areas where security can help, we need to look a little bit more. So there was a NIST study in 2016, so from 2008 to 2016, and the NIST study showed that nearly 73% of all issues, all CVEs, are caused by implementation. This is code. This is writing code. This is the area where mostly we spend our time as security people, at least general security folk. So most of the time dealing with design, secure design, dealing with configuration. Have we used hardened images? That's where we spend most of our time. The other part of the problem is that this is security. How many people at Achmea involved in AppSec?
On the security department, 40.
40 in 13,000 people. How many developers?
I don't know. But we have a lot of security champions.
Okay. So this is how you're scaling. You're getting it into the teams.
Yeah.
Cool. Was there a question at the back there? Was there a question?
Misunderstood what you were asking.
So, application security all sits down here. And most of the time, most of the things that we're doing in application security is going to be things like annual pen tests. It's going to be things like design reviews, when you're notified of changes that are going to happen. And it gets measured against the number of instances we have, which is a terrible measurement. Because as we said, instance is a trailing indicator. So, if you wanted to ensure that performance was the key attribute, the number one thing that your code had, what are the things that you would expect to be doing to ensure that that was the case? Well, the text down here is tiny. I can't read it. The one thing you'd be doing is to ensure that you have clear requirements for the level of performance you expect. And I have somebody else read it because I'm turning around to face the screen. What's the next one?
Performance.
So think about what the impact on the performance would be for any changes you're going to be putting in place. So performance is going to be highlighted in everyone because these are full performance, right? How do we go about doing performance? You're going to plan your architecture with performance in mind. You're going to have that as a fundamental aspect of how you're going to think about what the architecture should look like. You're going to ensure that everyone knows how to write performant code. You're going to have devs who are good at writing code that's fast. You're going to hire people with domain expertise in performance to train and to work with the teams in the wider business. Right? I see smiles in the room. I think you know where I'm going with this. We're going to have peer-review code changes. We're going to peer-review all the code changes to make sure that none of the code changes are going to impact the performance of the system. Because if they are, we take that back. We're going to share knowledge, known performant code, so code that we know works fast. That's going to become used in all parts of the business. We're going to use it everywhere. We're going to make performance a key consideration in the selection of any third-party services. We're not going to use slow services because they're going to slow us down. We're going to automatically test changes for any performance reductions, any regression for performance. So we can fix them early. We don't want that non-performant code getting out there. We're going to prioritize performance fixes in our backlog. When we find fixes that will improve the performance, those things are going to get pushed forward. They're going to be the important ones. We're going to inject comprehensive telemetry. We're going to measure that performance is happening. We're going to monitor for performance. And we're going to investigate and fix performance incidents in production and widely publish all the findings we have, all the lessons we've learned from that. And we're going to have responsibility and accountability for performance with the people building the system. If I want to do that for security, I'm going to do all those things with security in mind. Right? You don't write secure code accidentally. You don't have secure systems accidentally. It's an explicit choice. If security is important to this thing that you're writing, then these are the things you need to do. But how do we scale that up? How do we make sure that, so for example, we need to make sure that everyone knows how to write secure code. That's a key component of this. We kind of talked about it a little bit. We need to check build and test logs to make sure that we're having no security issues, that there are no low security concerns coming up. Need to check Jira or whatever your backlog management system is to make sure that the security fixes haven't been deprioritized, haven't been pushed off. So this is SRE. You mentioned DevOps. Does anybody here actually have site reliability engineers in their organization? Yeah? A couple. So SRE, this is their role, right? Their role is to ensure that they are the reliability experts. They're the ones who know what code should be looking like and how it should run in production. There's some launch engineers who work closely with production teams to educate and set them up for success. So these guys, the SRE team, are doing for performance all those components that we were talking about, or at least they're providing the skilled knowledge for your dev teams to be able to do that. And then there's this back pressure, like handing the pager back. They will run your code for you. SRE are running the code for you in production. So as a dev team, you can carry on building new features. But the moment your code starts to slip, the moment the performance levels that your code has starts to drop below that, they're going to hand the pager back to those teams. They're going to say, listen, we're no longer on call for this thing. Here's your pager. Now when something goes wrong, you deal with it yourself. You're back to an old school DevOps operation. You're back to you build it, you run it. Which means that you're not focusing on new features, right? That team no longer has that ability. This operating model works. Can we apply the same method to security? Can we do this from a security point of view? Product security engineering is what I'd like to introduce to you. This is how we're doing it in a lot of our customers. Can you hear me at the back there? Okay. You wish I had the microphone up. Let me grab some water. So product security engineering. It's the same, just being part of an engineering function, right? So where we've got here site reliability engineering doing these things, product security engineering are providing self-service platforms, automation, and doing all their own work as much as automating their work as much as they possibly can. They work closely with product teams, and they do a lot of education. They're doing the same things. The differences come in here, right? There's service level objectives. Those need to become security level objectives. The service level indicators need to become security level indicators. So for those of you who don't have SRE teams, service level objectives are the set baseline that we have for this is how performant this code needs to be. This is how we expect this to run in production. The service level indicators are the ways in which we measure that. So we need to be able to see, we want to be able to handle 50,000 transactions a second, and we can tell that there's lagging if we see, or we have to have 50,000 transactions a second. We can see that those issues are lagging when we see that there's a spike in CPU usage on a particular type of transaction. So the objective is the 50,000, the indicator is that CPU spike. So we need to do the same thing for security, right? How do we measure what is the objective we have from a security point of view, and what's the indicator? How do we know that we're going to have issues with that objective down the line? The pushback in the SRE world is, okay, it's not performant anymore. You're going to be woken up at 3 o'clock in the morning when the performance drops below a certain level, or when customers can't work on the system in whatever way. For security, it's slightly different, right? There are a number of ways to do it, either positive or negative reinforcement for teams. These two options, one of each, are ones that we find work. The positive reinforcement is you have an express route to production. The trick is they need that express route to production anyway because we don't want to slow them down, right? So if you meet all the requirements, if your security level objectives are good, so security level indicators are showing us that you're doing the right things, you go straight to prod. The negative reinforcement is the information radiators. How many dev teams have got the giant dashboards up near their workspaces in your organizations? Do you still have those, the information radiators? It works less now that we're not physically in the same offices. But something like that, information radiators that perhaps are visible through their Jira connection, like this is how well you're doing from a security point of view, do tend to work. So we need to be able to answer the questions, who's contributing the code? So whether that's code actually design or product decisions, who's making the choices? Which subcomponents make up the whole? Which pieces are we talking about? Because microservice architecture is still a thing, and even if it isn't, you're pulling in libraries from different places. So how do you create a bigger picture? And from the bottom up, you need to be able to go from the repository. So, can't see where it is, but you need to go from the repository that has the code in it, all the way through to this is the product that's running, and this is how secure that running product is. If you can't do it from an engineering point of view, then you'll never be able to do it from a security point of view. So it's important that your teams are able to say, these repositories, these pieces of code, build together to form this artifact. This artifact and this artifact run together in this production system. That's the code that we have. That's the system, the service that we're running. This is an example of one of those dashboards. This is a mock-up of a dashboard that we created for a customer. If you can zoom in really carefully, you can see the tiny data points on there. Seba might recognize that what that graph on the left might be. That's SAM, and that's the ASVS. Looking at the two components of this is SAM and that's ASVS. Looking at the components of what we're doing. So those are already two projects that we use quite heavily to measure the quality of a product. You might not need to do all of this. See, there's a number, a big number that makes it easy for the manager of the organization or manager of the dev team to know this is how well we're doing. This is what we're expected to do. That's how well we're currently at. And they're all just calculations based on what you've been doing over the last portion of time. So where are you from the expected point of view for SAM and ASVS? So what is your expectations to have in those areas? What have you achieved in those areas? The team that's currently developing, the people who developed and pushed code to this current release, have they had their training? Are they up to date? Have they scored well in that training? Is there an annual review coming up? Is it passed? These all add up to determine whether this particular product has a good score or not. So that's the overall security level objective that's agreed. As I was saying, these are the measures, direct measures of software quality. What might this be? What do you think these things might be? There's a couple of OWASP projects that we're pulling data in from usually here as well. So it's things like dependency checker and things like ZAP. So your DAST SAST, IAST if you're using it, and SEA. These are those measurements that are appearing here. How well are we doing? How many issues do we see? High, medium, or low? And we talked about the up-to-date security training there as well. The back pressure is important, right? We're competitive. No teams wants to be the one who's performing the worst. No team wants to be the one with the lowest score. So this does work. This dashboarding does work because they will compete to see that they're above the rest. So there are going to be lots of talks that talk about the cycles. The part in bold is the part that I'm going to talk about, primarily because that's the part that we see helps us to scale best. That link was the OWASP Black Hat talk I did a couple of years ago. A talk at Black Hat for OWASP on OWASP slide deck material. Awesome. And it's well worth taking a look at. It talks a little bit more about how the projects fit together. Talks a little bit more about where all the components come apart. The talk is called RU-BFG, red unless blue finds green. And it talks about the projects that we have as OWASP for red team, projects we have a blue team, projects we have a green team. And there are different projects. There are lots of projects. I mean, you guys are aware of that. And it's quite an interesting way of trying to get an idea of the landscape of projects. So that brings me to secure software development training. So the how to do secure software development training. So this is an attempt to standardize and codify a curriculum for secure application security. So secure software development. This is an OWASP initiative, the stuff that I'm about to talk about. As an organization, we make use of it, and you should too. Some of you already are, and you'll see I'll be talking about SAM in a couple of seconds. So the ones that we make use of, as you can see here, I talk about the OWASP Top 10. It's an important project. It has very specific uses, and probably not the uses that most companies use it for, but it is important. I talk about the Cornucopia. The reason I decided to pick up the project or to take on some of the work in that project with Con is because I find it an important project and it needs to be updated. It needs to continue to move forward. It's how we do threat modeling. I'm going to talk about application security, the ASVS, about the standard that we have for security, and I'm going to talk about SAM very briefly as well. Okay, so yes, standing on the shoulders of giants, it's important. None of the work that I'm doing is any way, shape, or form to take away from what is done here. Without these projects, the application security curriculum project can't function, doesn't work. So, starting off with awareness. And I said that the top 10 has a very specific role. It's awareness. It's not supposed to be a standard. It's not supposed to be a way in which you measure whether your developers are doing well or not. It's just to give them awareness. The top 10, although there are now several top 10s, I'm talking about the original top 10, the one that was recently updated again, is where most teams start to talk about application security. It's where most teams first hear about OWASP. It's usually the top 10. It's even been referenced by PCI DSS as an important part of application security, but it is not a standard, right? The top 10 team have said so multiple times. It's not a standard. This is the top 10. I'm not going to run you through it because I'm sure you've seen the top 10. The big difference, or the reason this slide exists, was to show the mapping from 2017 to 2021. So this is the new version of the top 10. If you haven't had a look at the new top 10, which I doubt is the case, it's worth taking a look at. What you can see is the trends have been fairly consistent, right? We're still seeing a lot of the same stuff, which isn't great. So this comes straight out of the application security curriculum template slide deck. This is the first component that the application security curriculum have released. There is a top 10 course. This is the ASC foundational course. It takes them through the top 10, and it gives you, this is a slide straight out of there. This is available. In fact, so this is the slide that shows the structure, the rundown, what we expect to do on a top 10. This is an example slide of one of the specific ones, so broken authentication. This is what the slide looks like. It gives you an example. It gives you some text on what's going on. And you can see that when I pasted the slide into my slide deck, that example kind of slid up slightly. And it provides some speaker notes on each of the slides, because sometimes you need a little bit of help to help you get through what you're talking about when you're presenting this to a dev team. It can be found here. I'd like to give a quick shout out to HMRC. The only reason I was able to build this and publish it is because I was having to do an awareness session for HMRC for their dev teams. They have way more devs than you would imagine. They're way more modern than you could imagine a tax department being in how they develop. A lot of their devs are externals, so they don't have them in-house. They generally come in through one of the 3 large dev groups in the UK. But because they wanted to do this, and because they had me on payroll at the time, or had me on contract at the time, they paid me to put it together and then said, yes, of course you can publish it and make it part of the open curriculum. So you have them to thank for that. Moving away from just the baseline of this is an awareness of what you should be aware of, is the next step is understanding, helping dev teams to understand what they need to do. And that's Cornucopia for me. So why Cornucopia? Because I'm involved with it. It's kind of like the OS Top 5. I say that a lot. I'm involved with it because I think it's a good way to do threat modeling. It helps dev teams really understand what it is they need to do. And it helps you, because it's a game, and because playing games with devs is far more fun than taking their stuff, their beautiful baby, and saying it's ugly, and then ripping it apart, which is what threat modeling is otherwise. It works far better, I find. It stands on the shoulders of those giants again, because it also leverages the ASVS, and it also pulls things from secure coding practices, and it just is a good way to pull together some of those projects in an easy way for devs to understand. So, Cornucopia, reach out to me if you need a deck of cards. I'm going to be getting some more printed. I have 2 or 3 at home, so ping me soon, and I'll get you those 2 or 3. But I'm going to get more printed up because there are new versions coming out, and those new versions will have a QR code that will take you to a website where those links out to all the projects are. So you can still play the cards as normal, but instead of just having a list of references, which the cards currently have on the bottom, it'll have a QR code that will take you to a digital version of those references, so you can actually click on and click through to the ASVS, or to SAM, or to SCP, or whatever it might be. I do have hours on this. I've presented many times on Cornucopia. I am a huge fan. If you're not using Cornucopia, talk to me today and explain to me why, because I'd love to know why. So there is a video there that explains how to play it. Reach out to get that. Take a look at it. It's a quick run through, less than 15 minutes, and it'll actually show an example of a couple of rounds. It's very professionally filmed. Just ignore the bearded guy, who's the only non-professional thing in that whole movie. I have lots of slides, so I'm going to flick through these quite quickly. But if you haven't heard of Cornucopia, as I said, is the top 5. As you can see, there's 5. No, there's not. Anyway, top 5. Auth-N, so authentication, which is who you are. Auth-Z, what you're allowed to do. Session management, which is how often we check Auth-N and Auth-Z. Mostly because session management is web apps. The original Cornucopia deck is for web, actually for an e-commerce site. But in the way the cards get played, it's basically how often we check authorization and authentication. Cryptography, which is the secrets, the hashes, the poor choices, you know what I mean. Obfuscation isn't Anyway, moving on. Data validation and coding, which is every pen tester's, every red teamer's favorite, because that's the way that you scratch the first piece open. And really, it's just about trust boundaries and understanding what trust boundaries are. And I go into a fair amount of detail on that in many of my presentations. Talk about it. And then, of course, I said top 5. This is the 6th suit. The 6th suit is the Cornucopia suit, which is the catch-all. Everything that didn't neatly fit in one of those 5 boxes ended up there. And it's also the trump suit. So it's an important suit when playing, although generally when we're teaching teams to play, we do not include Cornucopia in the beginning, because the mechanism of trumping each other makes the game more complicated than it needs to be to start. So how does Cornucopia fit into application security? Well, how do you make it work? You give them the game. You use the game. So give them the cards or give them access to a digital version of the game, which we have. And I probably have a slide on just now. And if I don't, reach out and ask me about it because we built one. I bet my business partner that he couldn't build one in a weekend. And then I ended up buying him dinner because he did. He got a large case of light beer and got him up to just the right bomber level, and within a weekend he built it. So what you want to do is you want to actually get the game, teach the game to developers. And then you want them to play it. And you encourage them to use the cards at every sprint when they're looking at the backlog, the story scrubbing for the next portion of work, because they're already doing the work there. What you want to do is not play the game with them, because you're the security guy. If you're the security guy in the room, then they're going to feel awkward playing, look at all the bad stuff I've written. So you generally want to teach them how to play and then let them play it on their own, and then just check the backlog to make sure that they're tagging their stories with, hey, this came out of a threat model session. It's like playing Cards Against Humanity with your parents. So, again, yeah, it covers off, are they, and covers off the auditors asked. This is the JIRA question. So if you check to make sure that they are doing threat modeling, you'll be able to see it because they're either adding, depending on how you've had them do it, they're either adding new stories to their backlog as part of a particular epic, or they're adding security-related non-functional requirements to stories. In both cases, as long as they've tagged those stories, you can show the auditors, look, we've done threat modeling. And that's important because a lot of organizations are requiring threat modeling, especially if you're doing anything with the US. It's become a requirement there. Talk from last week. Anyway, so how does it work when your teams are distributed? Well, we've created something called COPI. Secure Delivery built this. As I said, I bet Toby he couldn't do it in a weekend, and he did. It's available on the Secure Delivery domain as well as the ProdSec domain. So it's available on our commercial website, but also on the publications that we have out there that are Creative Commons. It's completely free. In fact, it's so free that when you create a new game, there is no login. There is no identity. We don't want to know anything about you. We don't know anything about your organization. So when you go out and create a new game, it just gives you an endpoint. That endpoint, that URI, is unique. If you share that endpoint with the teams you want to play the game with, they'll be able to join the game. If you share that endpoint with people you don't want to play the game with, they'll also be able to join the game, so don't do that. There's no login, there's no secrets, there's no passwords. When you then actually join as a player, you'll get another unique endpoint, which is your hand of cards. That means that you can take that hand of cards and you're sitting at your desk and you want to go sit outside and enjoy the sun. You just text yourself that onto your phone or onto your tablet, go sit outside in the sun and carry on playing the same game. It will be your hand. If you share that URI with other people, they'll be able to see your hand. So don't do that unless you intend to give them your hand. It actually allows you to either play Cornucopia or Elevation of Privilege if you're using EOP instead of Cornucopia. Again, talk to me. I want to know why. But because the gameplay is identical and because Adam Shostak and I often have discussions around whether it's EOP or Cornucopia, I put both up there. The cards are they're relatively easy to generate from YAML, so the game runs just as well with either. Yeah. So, copy.securedelivery.io or copy.prodsec. When you're busy playing, as I said, this is what the handle actually looked like. That slide is incredibly blurry, or is it just me? Very blurry. Okay, so this is if you're viewing the game as a third-party participant. So if you're the security guy and you're peeking in on the game and just want to see how it's going, you're not in the call because they're on a Teams call and they're talking to each other. So you don't actually hear the discussion around the cards, but you can see the cards as they get played, and you can see who's scoring. This would be the score. This would be how many cards they have left, and this will be the total score because there is a high card bonus for winning a round. If you've never played Cornucopia again, check out the video. There's a little thumbs up icon there, which is highlighted. This is how teams determine whether a card scores or not. It's very democratic. You have to get more than half people to thumbs up your card, and you can't vote for your own card. Seems reasonable. Moving away from just awareness into actual education. So we're doing industry, tertiary. How am I doing time-wise? Yeah. So how do we go on to education? How do we do tertiary education? And there are two possibilities, right? And this is where a lot of the work is still happening. Now that developers are aware of what security is, they know what OWASP is, and now that we know that they have an understanding of what is expected of them, how do we help them to build code that is actually secure? Well, we measure how their code is using the ASVS. So we measure the quality, the security of their code using ASVS. So surely, if they built it with that in mind, they'd be building secure code. So it makes sense to me that we would take the ASVS and reverse that into this is what we need to do how we need to build things in order to build things securely according to the ASVS. So think of this as the build a secure thing part, right? So why do we use the ASVS? Well, it is a standard, and it has gone through a lot of rigor and scrutiny. There is a version 5 of ASVS coming out soon. It is probably the biggest jump that they've made, the most amount of work that's gone into it, but every version of the ASVS has been very thoroughly, rigorously tested and looked at. Version 4, if you're using it today, is already incredibly clear, incredibly concise. The 1,000-foot view of the ASVS, in case you've never heard of it. First thing you need about the ASVS is that there are 3 levels. So 3 levels there on the left-hand side. Each is applicable to different types of applications. So all applications should be level 1. Some applications might need to be level 3. Level 1 is for everything, and tools like Zap can be used to test for it. So all apps should be used at level 1. Zap is a good way to test for level 1. You should be able to test everything at level 1 with a DAS tool, with an automation tool. You can automate that level 1 testing. Every app should probably get tested to at least level 2. But to go beyond level 1, you need to do a little bit of code review. You need to look at how things are being built. You need to do a little bit of architecture review. So there's a little bit more work involved in that. For level 3, those are apps that are serious about security, right? So that should be on level 3. Slides with too many clicks on it. So level 3 is about things that are actually serious about security. And if you manage special types of data, you should look at that. There is technically also a level 0, but nobody refers to it. And level 0 is basically we have started testing using ASVS, but we didn't pass at level 1. At least that's my understanding. If you use level 0 as any kind of, like, you have met a certain requirement, make sure that you're explicit about what that means, right? What does a level 0 pass mean in your organization? Because I have seen it, and it does vary from organization to organization. So you always have to be clear. Learning areas for the ASVS covers everything from architecture, testing in level 1, all the way through to configuration, which is very tested in level 1, because we're doing DAS testing, obviously. And it includes all the domains from Cornucopia. So authentication, access control, session management, validation, data validation, cryptography. At level 3, you have to cover off 286 components, 286 requirements. But how do we break this down? How do we start teaching this? Well, we break down all the ASVS requirements into actions and terms, and we group those terms, so yes, all 286 of them, and we group those terms into units, and then we weigh the actions described against Bloom's taxonomy. Yes, it's a slow process. This is Bloom's taxonomy. If you've never heard of it, never seen it before, or more accurately, the cognitive knowledge domain of the taxonomy describes the 6 levels, and it starts with remembering and goes down to actually creating. And it is theoretically possible. There, as far as we know, there's nothing in the standard that appears to be a 6, so nothing that requires a ability to create things. And we've also seen that there's nothing less than a level 2, so nothing less than understanding is necessary. So the process is pretty simple. We take requirements from the ASVS, like this one. This is an ASVS requirement. We identify the actions in that requirement, highlight those actions. We identify and collate all the terms. So these are the terms that we think are in there. And then we apply some magic to determine Bloom's level required to fulfill that requirement. So we then have to go and find information to go from that. We have to go find information on each term, and perhaps make a note to the author, to the standards authors, about questions we have. So this is the note that went out to the ASVS team on this particular one when we were going through the process. And then potentially add a knowledge-based article on OWASP about this. In this case, there was actually a good reference there that we could use. So if I haven't written this yet, feel free to take a picture and go and write that article. Add it to the community of knowledge. And then we have to build teaching materials using all those terms grouped by units so that they make sense, right? We're going to teach this in a logical way. Now, we covered ASVS in tertiary. How do we turn this into a practical policy? So how do we make how we build code? So building a secure thing, and this is now building a thing securely. So we've built this, we understand what's necessary to build a secure product, but how do we go about building that product securely? And this is OWASP SAM. So when it comes to telling folks how they should software security, you probably want to be fairly prescriptive, which is one of the reasons that I like SAM over BSIN. One of many reasons I like SAM over BSIN. Feel free to ask Seba about Sam. He's right here. And if you're lucky enough to be in the training tomorrow, then you're going to learn a lot about Sam, which is good because I only have 10 minutes to complete the presentation. The 1,000-foot view, SAM is made up of business functions. Each business function is a category of activities that organizations developing software must somehow perform. So there are 5 business functions. Each has 3 practices. And there are 2 streams. I guess they're called streams, right? 2 streams. And then within each stream there are individual practices. And if you did that all, you'd end up with 90 of them. So 90 things. It's way less than 286. Much easier, right? The learning in SAM covers all these areas. So from governance and education, hey, that's an idea. Let's do some education. Through to operational things like managing incidents, right? So it covers the whole life cycle, the whole process. As before with SAM, we take the as before with the ASVS, we take SAM and we break down the activities into actions and terms, and we go through the weighing process. So there are fewer activities in SAM than there are requirements in ASVS, which is yay. But the activities are more complex. It's not as simple as, do you have this security header, right? It is more complicated. So it still takes time. We follow a similar process before, but this time we gather for a given function practice stream and a given maturity level. We gather the actions, the verbs, the concepts, and the artifacts. And then the intended output here is actually something like this. right? So we end up creating a policy statement that reads like that, which covers off what's necessary. So if you're doing this, you can answer the question, do you have solid knowledge about the dependencies you're relying on? This becomes the policy statement that gets used to determine whether your teams are actually meeting the requirements of your policy. How do we do this in practice, though? Well, go and do it. Right? Foundations is out there already. Go and make use of it. Please download it, share it with your teams, present it to your teams, talk them through it. Make use of what we built. With understanding, use the games, right? So ASC 101 is out there. With understanding, yes, please play the game. Play COPI. Use COPI online or ask me for cards and I will get cards printed and make use of them. Actually, the last cards that the OWASP Foundation had, I had them sent to DEF CON this year and they were gone in minutes. I was hoping that there would be some that would come back to Europe with, but unfortunately, decks of cards, who would have known? It's a great handout. When it comes to actually tertiary and industry training, look, it's still a work in progress, right? There's a lot going on. All of the ASVS and all of what we're doing with Sam. I'll be chatting to Seba hopefully today still, but definitely in the coming weeks around what we're doing from a policy point of view, because those policy statements, we intend to publish them to make them available to you as well, so you can just grab them and use them in your teams. There's a lot of great work being done in ASVS and a lot of great work being done in SAM, but sometimes there's some help needed to actually make it practical, to be able to adopt it for yourself. But the point is, we're currently training a bunch of this stuff, using what we're doing. We're doing that for organizations, and we can come and do it for you as well. But the point is, it needs to become a standard, and it needs to be available to everyone. So please get involved. The Application Security Curriculum Project is an OWASP project. The YAML for the work that we're working on, that we're breaking down those components into, it's available. Go to the website, check out the GitHub repository, see where we're at, and feel free to jump in. We're going to continue to build what's there, because I'm going to continue to keep giving that training. So it will grow, and if you can help me get there faster, that would be great. What does the future look like? Well, as I said, help us complete the mappings and start working on building those modules, and then the units, and then creating slideshows, because all of those things need to happen, right? It's only useful if we've got a presentation that we can put up and start talking to teams about. Or sponsor the project, like HMRC did, either by engaging me and saying, hey, we want you to train us on this, and all that training material you're going to build for us, you're going to contribute that back to the foundation. That would be ideal. That would be perfect. There is also a grants process that Andrew's trying to kick off, which will help other projects, not just ours, get the money they need to do things that they want to do. And please give us your feedback. Right, my email address. Get hold of me, even on Slack. Reach out if you have any questions about anything I've talked about here. And that's it. That's me done.